Hello everyone, Namaskar, Raj Krishna this side, and today we'll be solving one more problem from trigonometric equation. And with the help of this problem, you will understand one more method to solve the trigonometric equation. One method we have already discussed in which we use factorization, but in case you get equation which is not factorizable, so then in case we use a quadratic formula, but for that we need to make something so that it looks quadratic. So we have cos x, we have cos square x. Why not change this sine square into also cos square? So for that, 2 cos square x, fine. 4 cos x, again fine. Equals to 3, write this as 1 minus cos square x. Now take the RHS to the LHS. So 3 is there. 3 minus 3 cos square x, when it will come this side, it will become 5 cos square x because 2 cos square x is already present. Now I have 4 cos x and I have a 3 to that side, bring it to this side. So this equals to 0. Does it look similar to a quadratic? If you take for some time cos x as t, so this is nothing but 5t square plus 4t minus 3 equals to 0. Wow, this is quadratic. You can use quadratic form. I hope you know quadratic formula. If you have ax square plus bx plus c equals to 0, then you find x by simply by minus b plus minus under root b square minus 4ac by 2a. This is just the extension of the completing square method. We get this by completing square method only. So here t will be minus 4 plus minus under root b square minus 4ac by 2a, simply 10. Minus 4 plus minus. This is for 5 into 4 is 20 into 3 60. I will have to check this out once again. Let's see. 2 cos square x plus 4 cos x, 3 times 1 minus cos square x. So minus 3 cos square x. Got that to the other side. So this became 5 cos square x, 4 cos x minus 3. Fine. Now b square, which is oh, I see. This will be 16. 4 square is 16. So I'll have to remove this. Oh. Eraser color which should be same as that of the background. So 16. Now 16 plus this is 4 5 20 60. So 16 plus 60, 76, which can be written as 19 into 4. 4 comes out as 2 and you get under root 19 down there. Fine. And anything else we can do? Yes, we can cancel 2 from numerator and denominator. You get this. Anything else? No. What was t? It was cos x. You get two things from here. Cos x is minus 2 plus under root 19 by 5. Now root 16 you know is 4. Root 25 you know is 5. So root 19 will lie somewhere between 4 and 5. 4 point something, let's say. So minus 2 plus 4 point something. So let's say 4 point something minus 2. So 2 point something, 2 point something divided by 5. Again, it's a positive value, and 2 point something divided by 5 will be 2 divided by 5 is 0.4, but definitely it will be lesser than 1. Okay, so fine, because cos, I was just checking that this should lie between minus 1 and 1, and it is lying, so perfect. What about this? Again, this is 4 point something. This is become negative 6 point something divided by 5. 6 point something divided by 5, you will definitely get something minus 1 point something. Okay, negative, but it is crossing that. It should be between minus 1 to 1, but it is crossing that from the negative side. So this is not accepted. I only want between minus 1 to 1, but this is not going to give us something good. So we have neglected this answer because this does not lie in the output of cos x is always between minus 1 and 1. Okay, so we'll reject this answer. We'll move forward with this answer, which is cos x equals to minus 2 plus under root 19 by 5. Now cos x equal to, now say me one thing, that cos of pi by 6 pi by 3 is half. So for pi by 3 you are getting half. So similarly there must be some angle, let's say alpha, for which we are getting this value as an output. We are putting alpha inside cos. Alpha is some angle, we don't know that because it is not looking good, and that is giving us this output. Okay, so let's suppose this cos x equals to cos alpha. So on putting alpha, you are getting cos alpha equals to this. Okay, so now cos x equals to cos alpha, and we write here that alpha equals to, alpha is some angle, so for which cos alpha is giving me minus 2 minus under root 19 by 5. Now cos x equals to cos alpha, we already know how to solve. Left bracket, if you put brackets here, equals to 2n pi plus minus right bracket, which is alpha. Now you have to mention that where alpha equals. Now how to find alpha from here? If you send cos to the other side, so that goes like cos inverse. Now this is something you have to learn, but for the timing just see that if alpha you have to keep in LHS and you have to send cos to the other side, this becomes cos inverse this. So where alpha is cos inverse and your n is an integer. So this is the answer we got for this problem. X equals to 2n pi plus alpha, where alpha is cos inverse minus 2 minus 9 under root 19 by 5. So let me see this problem once again. First, we have solved this by using quadratic formula. I have already discussed one method where we use this factorization to solve. Okay, and this time we are using quadratic formula to solve. Okay, in case factorization is not possible, we use quadratic formula. Reduce this to quadratic, take cos x equals to t if you are not comfortable with cos x being quadratic. Now then find the value of t with the help of quadratic formula, minus b plus minus under root b square minus 4ac by 2a. I hope you remember it. Now check the cos x equals to something, but that something should always be between minus 1 to 1. So in second case it was not, it was beyond -1. Okay, so we rejected that, we moved ahead with the first one. Here this was not a good value, so we uh, let alpha be some angle for which cos alpha is this. There must be some angle in this world for which cos alpha becomes -2 plus under root 19 by 5. So cos x equals to cos alpha, you know how to solve. Cos theta equals to cos alpha, theta equals to 2n pi plus minus alpha, just like same way. And here you have to write in the last, because alpha was your assumption, so alpha equals to cos inverse of, if you take cos to the other side, it becomes cos inverse. Okay, and n should be an integer. So that's what we discussed in this video. A very interesting example of this application of this method will be to find the value of uh, sine 18 or sine pi by 10. So if you are interested, you can watch that video. If you are stuck in finding the value, you can check out my video or give the comment. I will give that video to you. I have published that video on the other channel, but that is the application of this particular method. So that's it. That's enough for today. Thanks again.